I have a dream that one day
Example 7 deals with an application problem on APs, and it says that the lengths of the sides of a right-angled triangle form an AP. If the area of the triangle is 24, find its perimeter. So let's have a look at it. Now we can start by letting the sides of the triangle be x, y, and z respectively. So x, y, and z. We can also draw a sketch. So the sides are x, y, and z. Now notice that we have three unknowns to solve. So we need to set up three equations and then solve them simultaneously. We can get the equations from the information given. We're told that the lengths of the sides form an AP. So let's use that information. So our AP could be x, y, and z. Now we use the fundamental property of APs, and it says term 3 less term 2. So z minus y, term 3 less term 2, must equal term 2 less term 1. We can make z the subject in this equation. So z will equal 2y minus x. And this we can call equation 1. So equation 1. We need to set up a second equation. We are also told that the area of the triangle is 24. So let's use that information. We know that the area of a triangle is a half base times height. So then a half x times y must equal 24. In other words, a half base times height. We can multiply through by 2. And here we can make y the subject of the formula. This we can call equation 2. Now note that here we have z equals 2y minus x. And here we have y equals 48 over x. So we can substitute equation 2 into equation 1 and eliminate one of the unknowns, namely y. So substitute equation 2 into equation 1. So we have z equals 2y, but y is 48 over x less x. And this is 96 over x less x. This we can call equation 3. Now, we can come up with yet another equation by using Pythagoras inside this triangle. So, according to Pythagoras, x squared plus y squared will equal z squared. So x squared plus y squared equals z squared. We have three unknowns in this equation. But in equation 2, we have y in terms of x, and in equation 3, we have z in terms of x. So we can substitute equation 2 and equation 3 into this equation, which you're going to call equation 4. So substitute equation 2 and equation 3 into equation 4. So we have x squared plus y squared, but y is 48 over x. So 48 over x all squared equals z squared, but z equals 96 over x less x. So 96 over x minus x all squared. We now have an equation entirely in terms of x, and we can simplify it and then solve for x. So let's simplify this equation. We have x squared plus, and now we need 48 squared, 2304. So 2304 over x squared. On the right hand side here, we can square out this binomial. So it's going to be the first term squared. So we need 96 squared, 9216. So the first term squared will be 9216 over x squared. Then we need this sign. Then we need twice 96 over x times x. In other words, the first term times the second term times 2. So it's going to be twice the first term times the second term. The x's cancel here, and we're left with 2 times 96. And that's 192. Then plus the second term squared, which is x squared. We can cancel the x's squared on both sides. Now we want to get rid of the fractions, so we can multiply through by x squared, in other words by the LCD. We can bring the x's to the left-hand side. And we want 9216 less 2304. (6912). Now we can solve for x. X will equal the square root of 6912 over 192. Now, note that we only take the positive answer here when we take the square root on the right-hand side, since x is a length. So let's see what that comes to. So the square root of 6912 divided by 192, and it comes to 6. So x is 6. We want the perimeter of this triangle, so we also want the values of y and z. But in equation 2, we have y in terms of x, so we can easily find y. Y is 48 over x, so it's 48 over 6, which is 8. We also want z. In equation 3, we have z entirely in terms of x. So it's 96 over x less x. So z equals 96 over x less x. And this comes to 10. So now that we have the values of x, y, and z, we can write down the perimeter. We can just add the values of x, y, and z. So x was 6, y was 8, and z was 10. and this comes to 24. Let's look at your answers to this question. In the first one it says, Mary's part-time work earned her an initial salary of 7,200 Rand per year, which was increased by 600 Rand annually. Her expenditure was 6,400 Rand during the first year, and it was increased by 400 Rand annually. Use a formula to determine how long it would take her to save 6,000 Rand altogether. It also says, exclude any interest that she might have earned. We can start by setting up sequences for Mary's salary as well as for her expenditure. Let's start with the salary. Her initial salary was 7,200 Rand per annum, and it was increased by 600 Rand annually. So 7,200, and it says it increases by 600 Rand. So plus 600 Rand will give us 7,800, plus 600 will give us 8,400, etc. Let's set up a sequence for her expenditure. Her initial expenditure was 6,400 Rand, and it was increased by 400 Rand annually. So 6,400 plus 400 is 6,800, plus 400 is 7,200, etc. Now we can write down her savings per annum. So 7,200 minus 6,400 is 800. Then we have 1,000. So 7, 8 less 6, 8. And then we have 1,200. So this is the sequence that we are interested in, because we need to find out how long it would take her to save 6,000 Rand altogether. So we have an arithmetic sequence here, and we have A, the first term, which is 800, D, the common difference, which is 200. We have S sub n is 6,000, and we need to find n, the number of terms or the number of years. We're going to use a sum formula. And plugging in our values. So we have 6,000 equals n over 2 into 2a plus n minus 1 times d. We can get rid of the fraction by multiplying both sides by 2. So that's 12,000. We can simplify inside the brackets. So that's 200n plus 1,400. And we can multiply the n into the brackets. Then bringing all our terms to one side. We can simplify a little bit here We could get rid of two of the zeros in this equation by dividing through by 100 or even 200. So let's divide by 200. And now we have a trinomial which we need to solve. And we can factorize, or we can just use a quadratic formula. So let's use a quadratic formula. Minus b, plus or minus, but because we have a number of terms here, we're only interested in the plus here, because the number of terms must be positive. So b squared minus 4ac all over 2a. So 2 times 1. And we can work out under the square root. $289. So the square root of 289 all over 2. And we see that we get an answer of 5. So then to answer the question, it would take 5 years to save 6,000 Rand. So in the second question it says 55 round water pipes are stacked as shown in the figure. Determine the number of pipes that must be placed in the bottom layer in order to have one pipe in the top layer. So let's look at the solution to this. What's important to note here is that we are only given the first 4 layers from the top. So we have the first layer containing only one pipe, the second layer containing 2 pipes, the third one containing 3 pipes, then we have 4 pipes, and all the way down to the bottom layer. We don't know how many pipes there are in the bottom layer. So we can always start by drawing a sketch where possible. So we can set up a series as follows. In the first or the top layer there's 1 pipe. In the second one from the top there are 2 pipes, then 3 pipes, and we can let the number of pipes in the bottom layer be n. But this must all add up to 55. In other words, we must have a total of 55 pipes. So this is an arithmetic sequence or series where the first term a is 1, the common difference d is 1 as well. We don't know the value of n, the number of layers, but we are told that the sum of all the layers must be 55, or the sum of all the pipes in all the layers. So we can use a sum formula. So S sub n is n over 2 into 2a plus n minus 1d. And we can substitute in. We don't know n. D, of course, is 1. We can multiply through by 2 to get rid of the fraction here. We can also simplify inside the square brackets. and multiplying out on the right hand side, we can bring everything to one side and we have a quadratic equation. This, of course, we can factorize. So it's going to be n plus 11 times n minus 10. And we can discard the negative answer because n is the number of layers. And we can see then that n is 10. So the bottom layer will contain 10 pipes in order for the total number of pipes to be 55. In number 3 here it says, a theatre is filling up at the rate of 4 people in the first minute, 6 people in the second minute, 8 people in the third minute, and so on. After 6 minutes, the theatre is half full. After how many minutes will the theatre be full? We can start by working out how many people there are in the theatre after 6 minutes, because we know that this is when the theatre is half full. So we've got this arithmetic series. 4 people come into the theatre in the first minute, 6 in the second minute, 8 in the third minute, etc. And we have A, the first term, which is 4. D, the common difference, is 2. N is 6. We want to know how many people there are after 6 minutes. And we need to work out S sub 6, the total number of people in the theatre after 6 minutes. So we can use a sum formula. And we need S sub 6. And S sub 6 comes to 54. So there are 54 people seated in a theatre after 6 minutes. We also know that this is when a theatre is half full. So then the total number of people that can be seated in the theatre will be twice 54. In other words, 108. So total number of seats equals 108. Now remember, we have to work out how long it will take the theatre to be full. In other words, how many minutes it will take. So essentially, we're dealing with the same series, but this must add up to 108. In other words, we need to find 4 plus 6 plus 8, etc. equals 108. We need to find the number of terms here. So once again, we have A is 4, D is 2. We don't know N. In this case, the number of minutes or the number of terms. But we do know S sub n is 108. So using the sum formula again, we have S sub n equals n over 2 into 2a plus n minus 1 times d. And in this case, S sub n is 108. We need to find n. We can get rid of this fraction by multiplying through by 2. Simplifying inside the square brackets. Multiplying into the square brackets. And we can bring all the terms to one side. We have a quadratic equation in n. We can simplify it by dividing through by 2. And now we can use a quadratic formula to find n. So it's minus b, plus or minus. But in this case, we'll only take plus because n must be a natural number or a positive integer. So minus b plus the square root of b squared minus 4ac all over 2a. Under the square root, it comes to 441. So let's see what that comes to. And we see that n comes to 9. So n is the number of terms, which is also the number of minutes, and hence it will take 9 minutes for the theatre to fill up. In number 4 it says, the heights above ground level of steps in a staircase form an arithmetic sequence. So here's the staircase. The heights of the 3rd and 7th steps are 52 centimeters. And 78 centimeters above the ground respectively. And it says, determine the height above ground level of the 43rd step. Now, let's write down this information. The heights of the 3rd and 7th steps are 52 and 78. So that would be the 3rd term and the 7th term respectively of this arithmetic sequence. So t sub 3 is 52, and hence, writing this equation in terms of a and d, a plus 2d equals 52. We can call this equation 1. Then t7, the height of the 7th step, is 78. And once again, writing the equation in terms of a and d, a plus 6d is 78. We can call this equation 2. And we can solve these equations simultaneously. We can say equation 2 less equation 1, and the a's will cancel. So a minus a is 0, and we have 6d minus 2d, which is 4d, equals 78 minus 52. Which is 26. So d then is equal to 26 over 4. Which is 6,5. So the common difference is 6,5. And we can plug d back into, let's say, equation 1 in order to find a. So substitute d equal to 6,5 into equation 1. So we have a plus 2 times 6,5 equals 52. So it's going to be 52 less twice 6,5, which is 39. So A is 39. And we needed to find the height above the ground level, or above ground level, of the 43rd step. So we need the value of T sub 43. So using the formula A plus N minus 1D, A is 39, N here is 43, so N minus 1 is 42, and D is 6,5. And it's 312. So then to answer the question, the height above ground level of the 43rd step is 312 centimeters. Let's look at your answer to this question. It says, in a mathematics competition, the total prize money for the finalist is 30,500 Rand. Each finalist will receive a part of the prize money according to his or her position at the end of the competition. The table below shows the position of the finalist at the end of the competition and the prize money received. For example, the last person will get 100 Rand, the second last will get 250 Rand, the third from last will get 400 Rand, etc. And the first person, or the person who comes first, will get X Rand. In A it says, calculate the prize money of the finalist finishing 18th from last. So we can set up an AP starting with the last person. He or she gets 100 Rand. Then the second last person gets 250 Rand. Third last person gets 400 Rand. Then 550, etc. All the way up to X. So the first person gets X Rand. Now in A, we must find the prize money of the finalist finishing 18th from last. So 18th from this term, the first term. So we've got the first term A, which is 100. The common difference D is term 2 less term 1, so 150. We must find the prize money of the finalist finishing 18th from last. So N is 18. And we need to find T sub 18. So we can use the formula T sub N equals A plus N minus 1 times D. And we need T sub 18. So it's A plus 17 times D. So let's see what that comes to. R2,650. So T sub 18 is 2,650, and hence the prize money will be 2,650 Rand. In the second part of this question, in part B, we need to calculate X. In other words, the prize money that the student who comes first will receive. Now, we know that the total prize money available is 30,500. So essentially, the series 100 plus 250 plus 400 plus all the way up to x must come to 30,500. And we need to find x, the last term. In order to find x, we need the number of terms first. So we're going to use a sum formula to find the number of terms with. And just plugging in values, S sub n is 30,500. We need to find n. D is a common difference, which is 150. We can multiply both sides of the equation by 2 to get rid of the fraction here. Then simplifying inside the square brackets, and multiplying the n into the square brackets, we can bring all the terms to one side. We end up with a quadratic equation in n. We can simplify it first by dividing through by 50. And in 61,000 divided by 50 is 1,220. Now, we can use the quadratic formula to find n. So, it's going to be minus b, and of course b is 1. So, minus 1 plus or minus, but we're only going to use a plus here since n must be positive. It's a number of terms. So, minus b plus the square root of b squared, 1 squared, minus 4ac. This is all over 2a. We can first work out under the square root over 6. So we have 1 minus 4 times 3 times negative 1220. And at 14,641. And that must be square rooted. Now we can see what that comes to. And we see that n comes to 20. So we have 20 terms in the series. In other words, there were 20 competitors in this competition. And remember that we need to find X, the prize money that the person who comes first will get. So we have n, the number of terms now, and we can use the formula T sub n. T sub n equals a plus n minus 1 times d. T sub n, of course, is the last term, or the nth term, which is x in this case. So we can substitute in. T sub n is x. A was 100. N is 20, so 20 minus 1 is 19. And d was 150. So 100 plus 19 times 150. And it's 2,950. In other words, the person who comes first in the competition gets a prize money of 2,950 Rand. Let's look at your answers to this question. In A, we have to write down the number of dots D and the number of sticks S in the fourth figure. We can start by writing down sequences for both the dots and the sticks. So let's start with the dots. In the first figure, we have 6 dots. In the second one, we have 8 dots. And in the third one, we have 10 dots. So clearly, this is an AP with common difference 2. So then, in the fourth figure, we'll have 10 plus 2, in other words, 12 dots. Let's now look at the sticks. In the first figure, we have 1, 2, 3, 4, 5, 6, 7 sticks. In the second figure, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sticks. And in the third figure, we have 13 sticks. Once again, we have an AP. In this case, the common difference is 3. So in the fourth figure, we'll have 13 plus 3, which is 16 sticks. In the second part of this question, we have to determine expressions in terms of n for each of the number of dots and the number of sticks in the nth figure. So we really have to write down the general term for the number of dots as well as for the number of sticks. So let's start with the dots. We're going to use T sub n to get the general term. So T sub n equals A, which is the first term 6, plus n minus 1 times D, the common difference, which is 2. We can simplify this. And we see that the general term, or the nth term, equals 2n plus 4 for the dots. Let's look at the sticks. Once again, we have T sub n equals A, which in this case is 7, plus n minus 1 times D, and here D is 3. And simplifying this, we get 7 plus 3n minus 3, which is 3n plus 4. In the last question here, it says 100 dots are available to make a figure in the sequence. So we are given the number of dots. Calculate how many sticks will be needed for this figure. So we are given T sub n for the dots, and we can use this to find n, the number of terms. Because we know that for the dots, the general term is 2n plus 4, so we can make 2n plus 4 equal to 100, and we can solve for n. And we find that n equals 48. Now, the question says, calculate how many sticks will be needed for this figure. We've got the general term for the sticks as well. It's 3n plus 4. So then we must find t sub 48, but in this case for the sticks. So we merely plug 48 in for n here. So 3 times 48 plus 4. And it comes to 148. So then the number of sticks we will need is 148.